So long day, 3 p.m. already. I'm really tired. No? I'm Javier Lagares. I work for HP in the additive manufacturing business, which is a part of the print technology. I'm going to explain you, first of all, how additive manufacturing works, because you really need to know why our customers need the printer data, the telemetry data to manage their operations. I will go over why delta sharing was a game changer for us and how it helped in all this journey. Then I will go over the solution architecture, how we architect the solution and how we are delivering that to our customers. And finally, we will go over the benefits of getting this architecture in place. So if this wants to go, it doesn't want to go. Okay. So this is, you can see here the steps, the physical steps to basically get a print job full of 3D parts out physically from the first step in the process, which is the build unit and the processing station, into final parts. You can see here a cranial orthosis that is for medical appliances. And I will not go into the digital part of the design, because the intention for the customer is to place as many parts as possible into the build volume, which is something like this big. And when the build volume is full of parts, then the real printing starts. So the first thing that they need to do is to fill up this build unit with material, which can be of many kinds. The important thing of putting the material inside is do a correct mix of recycled material and new material. And this is what the processing station does. So the first step is to put the material, prepare the material for printing. The second step is to insert the build unit into the printer, where the magic starts. It will be a 10-hour process or 12-hour process, depending on how big or how the height of the job that you are printing. And you really need to control the temperature inside the job and melt the plastic in specific places. For that, you can imagine that every layer, which can be an 80-micron layer, you are printing a page, then you are applying heat, and then you go again and again for all this time. So this is like baking a cake, but with plastic. So next step is you have all your parts there. They are very hot. This is happening at 170 degrees centigrade. So you need to wait a little bit and then get this machine, put it into the processing station again, and unpack the build volume. After that, you need to go and cool. This cooling process is critical for crystallization and preserving the mechanical and properties of the functional parts. And it stays there for about 24 hours. After that, you get this same bucket, you put it into the processing station or unpacking station, depending on your workflow, and you start cleaning. After you clean, you are getting out the reusable powder for the next job, and you start with the process of post-processing, which can be sandblasting, painting, smooth surfacing, so you name it. That depends on the application. You can imagine that from the first moment where the digital part was placed in the build volume until the part is ready, a long time has passed, maybe 2 days or more. So you really need to control what happened in the full process, because if you are you work as a parts provider and you need to reprint this job because something happens, you really need to know as soon as possible what happened and when and why. So let's go a little bit on the fusing process. So that was the printing process, this small step there, which takes 12 hours. So it's a 4-step process. The first thing is to apply either of the 2 agents there. You have a fusing agent and a detailing agent. The fusing agent is what will absorb the heat later, and the detailing agent is basically an ink that is placed around the fusing agent, so the dissipated heat from the fused plastic does not fuse the non-wanted powder. Now, after this is printed on the powder, lamp goes on top of the layer and burns it. Basically, it will melt whatever was painted black. And during all this process, there's an incredible temperature control across the whole volume. So you need to manage whatever is printed so it keeps heat. Whatever is going to be printed is completely homogeneous in the build volume. So this is going to be like a 50-liter build. So it's a lot of volume to maintain homogeneously hot. After you print this layer, you need to go over the next layer. So we are talking about 5,000 layers there. So this works for the plastic. In the metal printing, it's a little bit different. You are basically gluing, bonding the metal powder, depending on the powder. And what you do later is you put that in an oven to melt the powder at 1,000 degrees. Let's see, this is the portfolio for the metal jet printing. A single part needs to go in each and every of these machines for different purposes. And it can take, as I said before, 2, 3, or 5 days to get the things ready. No? So controlling the printing process is key to success. So even if we have a great hardware and chemistry, we really need to do it well for repeatability. So you can have one job well, but for example, if the ambient conditions change, your next job can be ruined. So you really need to control all that when you are doing production. So other critical things why data is a must there, you need to detect anomalies. If your powder, for example, is degrading, is getting yellow, all your parts are going to be ruined. So you need to detect if your batches are going bad. As this is for production, the critical thing on production environments on the shop floor is to do preventive maintenance. So you have to understand when your machine is going to fail. You need to calibrate all these devices, auto-calibrate themselves, and send the information to the cloud. This is the only way to optimize throughput and uptime, which is critical in production and manufacturing environments. So instead of relying on regular or by default preventive maintenance on the machines, we are analyzing all this data and we are creating alerts so the customer basically can advance or delay maintenance, so they can take advantage of extending component life if a maintenance is not needed. Okay? With all this data, they can generate KPIs for the production process. So what they really want is get this data and feed them into their manufacturing execution systems. So when you get into regulated markets, and here you can see a picture of Invent Medical for prosthetics on a child. The HP equipment that is sending all the different steps, send data to the cloud, we really need to create what we call the DNA of the part. So for regulatory purposes, strictly in medical or aviation, you need to understand what is going bad or what is going good. So we are gathering critical data from the full workflow, and each machine in the workflow is a critical agent to understand what is going well. So you really need to compile the end-to-end information and create this traceability of what happened to the part. No? The same part can be really good print in the top of the bucket, we call it bucket, but in the bottom, because if you have a different temperature control, it might be bad. So you really need to know even the position inside the build volume. So creating this digital thread is critical, no? And it enables audits, quality control, and even reprints. If you know that your whole batch or part of the batch is getting bad, you really need to understand it fast, because the turnaround time for additive manufacturing is very short. So, and why we need a better way to share data? No? You can connect to our devices. You saw there in the metal printing or the plastic printing that you need to connect and extract data for 3, 4, 5 devices, no? Over 2 days, just to get a glimpse of what is going on in your production plant. And if you are a service provider that is printing with 10, 15, or 20 of these devices, managing all this workflow is a mess, no? It's a complete mess. So if they need to connect to each and every device and get the data via API, gather this information for days, then cross it out, no? All this JSON information. Some of them, they really need to do reverse engineering on what the hell this JSON is pointing to. No? We really needed to change the way it works. No? So delta sharing hides this complexity. Why? Because we are doing that work. We understand what the data is in these JSONs, how to cross it out. We create this virtual life cycle of the part, and we provide data products that will show, okay, for this part, this is the history. For this job, these are the parts, and this is where they were in the build bucket. So they can rapidly inject this code, this data, into their manufacturing execution systems, and then manage the operations in a better way. That frees their engineers to focus on what is really value for them. No? They want to not to maintain APIs, but to add value to their production. Okay? So delta sharing has eliminated the friction of accessing this machine data, and the teams on our customers just focus on decisions. No? Should I reprint? Should I start maintenance, a predictive maintenance? No? If you have an operation with machines and you have an unplanned maintenance, you have a big problem. So here I put like 3 personas that are real. No? The 3 people that have to get the most advantage of the 3D printing in production. So the first one is the traceability lead. No? You can think about this person explaining to the audit, no? Why a part went bad or good. No? They need to analyze any failed batch or understand cost variances. So for that, they need to get access to all this data. The quality manager, they need to understand also what is wrong between shifts or machines. No? Why this machine is printing better, or why, for example, these 2 machines that are printing in polyamide 11 or polyamide 12 or the TPU are failing. No? Is it a material batch? Is it a bad mix? All this is critical information. And then the automation engineer, which is the one that needs to get all this data and feed it into their systems. So they can merge the production system with the other machines' operations, and they can close the loop on how the performance is going on the plant. No? As I said before, predictive maintenance is key. So if you can plan for that in the weekends or in between shifts, is much better than stop the full production cycle. So how we did it? I'm going to go over the architectural blocks, then going into the data layers. The medallion architecture that we implemented is kind of different because of the functioning of our machines. I will show how the customers really see the data in a different experience. And then I will explain the different workflows that we are running, the analytical workflow and the data management workflow, which are two and different. Yeah? So these are the architectural blocks. There are three main components over here. The first one is the Databricks infrastructure. No? The second one is the API proxy. In our case, it's Apigee. And the third one is DeltaShare, which is basically the main point of this presentation. No? In Databricks, we have the layer architecture, which is what provides value every time it goes into bronze, silver, and gold. I will explain what this means in our case. And Apigee serves basically as a gatekeeper for the customer. We are hiding the Databricks DeltaShare token, and we are managing a different way of renewing that, having an isolation between what the user sees and what Databricks has behind. And DeltaShare basically simplifies the customer access. We were able to have a solution where dynamically we can add, remove, or update tables, not only data tables, but documentation tables. So the customer basically receives in the same schema the table with the data and a documentation which is actually updated every time a new version of the data comes. So let's go into the data layers. Okay? Some of our printers go into a print as a service, which means I don't pay for the printer, I get the device, I just use it, I pay for the usage. No? So it's critical here that the machine is connected to the cloud. And if it's not connected, we are going to disconnect it. The machine will stop printing. So that's the first thing. So in the landing layer, which is the first one, you see that up there, the landing layer is the one that will get from the object storage, will get the data, process it, and connect back to the printer to say, okay, I received this, you can continue printing. Okay? It's like a credit management system. Then we have the bronze layer where we are decrypting and deduplicating all the data. Our printers are entitled to send data twice or 3 times. They are very verbose, as we can say. And this data, the duplication comes there. No? The silver layer is the one that is structuring the data, ready to create the analytics. This silver layer is the same one as we are doing to create our internal data consumption. Okay? And the gold layer, in our case, is basically a split for a different schema and a different catalog. There is one catalog just for delta sharing, and every customer will have its own schema. So we basically and physically separate all the data per customer. So there's no leakage possible. Okay. So in the delta share approach, we are basically having a one-to-one relationship between the recipient, the sharing data, and the table. So we don't allow several customers to get sharing of data from others. No? If the customer is working with a partner, we can create a second share, and then we can share the data automatically. No? So if we go then to the API proxy, it has four main controls. No? The first one is the endpoint change. We are not showing Databricks endpoint for delta sharing. We are basically providing an HP URL for them to connect. So it's very simple, very understandable URL. Second thing that the API proxy does is a token swap. The customer usually uses an application, which is a cloud application that HP provides, and they will be the ones creating a token, which is then inserted into a JWT, and they use the JWT token to send it to Apigee. Apigee will validate this token and then swap the token by the Databricks one. The advantage of this solution is that the rotation is independent from the user and from Databricks. So this is the second point which is critical in our architecture. No? And the typical other functions of the API proxy are the rate limiting, the quota, so the users behave. Okay? The last one, which is interesting, is the usage statistics. So as delta share codes the schema, we have one schema per customer. We know basically by looking at the URL, which is the customer accessing that data. We are then looking at the table because the delta share also shows the table, and we get statistics and insights about which tables are useful and why they are using and how they are using these tables. So in the execution workflows, which is one of the two workflows, we do several things. No? The first thing that we do is after everything is managed into a metadata-driven table. What this means is that if we have a customer, it will have a line in this table that will say, okay, this customer needs to run this data product at this rate, and it will run every day. And it has to have data for 1 month or 3 months. So this is what the metadata-driven table tells for every customer. So we have a bunch of different data products, and we can select which product goes for which customer. No? This even enables us to have bespoke or by SOW data products for specific customers. And they will be the only ones that will get this data. This is critical for some specific applications. Okay? So once the metadata-driven table is read, the workflow is created, an orchestrator that will run the different notebooks all in parallel, and that will update the data every time it runs. If in a given iteration, some customers are not needed to be updated, the workflow won't update it. No? The second thing that it does is every time it runs, it will check for token expiration on the customer. So we can basically manage the token expire in the same workflow, no, at the given rate. The next thing that it starts doing is adding information to schemas and creating the documentation. So here we do 2 things. On the documentation, we use Databricks also to add tables with each and every column and the meaning of the column to the customer. This is automatically done using the Databricks LLMs and injecting the SQL that will generate the data product. So automatically, we don't need to document 200 columns. This is going to be done automatically every time we release a new version of the data product. Yeah. After that, we can inject some resource tables for business intelligence, which are typically upper and lower bounds or the KPIs that the machine needs to go between. No? So this is critical for the customer, so they can know, just looking visually, if they are in the correct ranges. No? And the last step is to ensure that the ownership for each and every table is correct. So we run and we review the ownership, we set it up again. So let's go into the analytics workflow, which is the one that is going to track usage and tell us which tables have real value for them. No? We have data products, and we need to track how users are using it. No? So as I said before, we analyze the URL, we connect to Apigee in a workflow, we get the data from the Apigee tables, and we create our own analytics in DeltaShare. We enrich them with customer data, and then we have a full-blown BI dashboard of which tables are useful, how are they doing, when are they using them, okay? If adoption gaps exist, if a customer basically is paying us because they want some data and they are not using this DeltaShare, we can contact them directly and tell them, okay, why are you not using this feature that we created for you? No? Also, it helps validating the value of each table. No? When you create a data product, you want to see who is using it, not only individually by customer, but also by sector. So maybe one data product is very valuable for one sector or another. So this is a timeline view of how the beta went. No? You can see how often the customers are refreshing data, and you can also have a similar view for the different tables. So really, in a small amount of time, you can see which customers are really utilizing the DeltaShare solution that we give, how they are doing. Are they refreshing on weekdays, on every day? Are they getting the data once, 100 times? So this is where the type of data that we can get from the analytics. No? So once you have all that, you want to know which is going to be the bill. No? And we have here three different areas. We have the data storage costs, no, for DeltaShare exclusively, because there's a catalog dedicated for that. There is the compute cost and the API proxy cost. No? So on the data storage cost, this program, at least with these customers that we are engaging, only provides data for 1 or 3 months. So the amount of data the data product has is very small. So we don't care about these storage costs. No? On the compute cost, as we have optimized the workflow of execution, the cluster starts, refresh, and shuts down. So the total amount of DBUs that we consume is very small at the end of the month. So it's not a problem for us. No? And the last one is the API proxy. So we were concerned that if the user start getting the data, all of it from the API proxy, it will be charged twice, no? From the egress cost and then the API cost. Good thing is that the API proxy is only used for the initial calls. No? Once you have the response of the Parquet tables list, you go directly into Databricks. So you don't use the API proxy for that. So if we look at the value for the customers, trying to summarize in a little bit. So we have seen how we simplify data access. No? If you want to build a solution that connects to 20 machines, and then you have to add another one, you need to redo or review your infrastructure, no? To connect to this one and to add that data from the machine to your results. No? Customers don't need to manage complex APIs anymore. They just connect to the same URL. They add another printer, it appears magically. No? So that relieves a lot of operational efficiencies. So it helps a lot on the operational area, because it reduces the dependency to have a backend team looking at the ETLs of the APIs. No? The customer is really satisfied. You will see now in the next slide the real quotes from customers that try to access the data using APIs and change to Delta Share. No? And the good thing is that it's a scalable and secure architecture. You can go and grow, the solution grow as you go. You get one printer, you get one device, you get 10 devices. You don't need to change anything in your infrastructure. It's automatically aggregated. So if we go into customer testimonials, you can see what they had before. Accessing the telemetry via APIs meant that what I said, a customer had to understand the API, dozens of JSON payloads, and it was very time-consuming. When they migrated to Delta sharing, we'll go into uptime and zigzag. These are the biggest in US and EMEA 3D parse provider. So they serve across Europe and across US. So they were very happy. If we go into zigzag, they were using the APIs. It took them more than 3 to 5 months to integrate or to try to integrate data into their workflows. It was 0.5 days, so not even a day. The data engineer had the data in their systems in 4 hours. Okay? Same happens with Ocado. Ocado is a grocery company which developed a robotized way of warehousing, and they are now selling the warehousing as a business. No? So they use that 3D parts into their robots, so they can increase the turnaround time of having new parts to manage the groceries. So as a summary, the key takeaways: we are not sharing data. We are enabling business value through data. No? We are relieving the pain of connecting to different APIs, different devices, and get the data out of it. Maintaining this is a burden that the customers don't want to do. No? The goal is not the telemetry ingestion. It's for the customers. Is automating, getting operational efficiency, and getting smarter operations. No? This solution is improving quality, helping on scaling their operations, and innovating in their own products. They don't need to innovate on how they get the ETLs out of the data. No? They just focus on manufacturing. No? So this is the path that the HP and the additive manufacturing business is committed to continuously improve how we deliver data and how data helps our customer transforming their business. There's some time for Q&A. If you want to do the survey, we will have time. So, yeah. Thank you.